Hey guys, it's Miss Dean. I hope you're doing well. I know you're excited to know that we are starting Ideal Gas Law. It's the last gas law that we will be looking at. This is the Ideal Gas Law because it's looking at all of the conditions where they're not changing in gases, and it brings all of those gas properties together. So our formula for ideal gas law is PV equals nRT. And there's several different ways you can solve ideal gas law problems, but I'm going to show you what I think is the absolute easiest way to solve it. So if you make sure that you stay in particular units, then this is super easy to solve. So when you're doing this, you want to make sure that when you're talking about P, obviously is pressure, you want to be an ATM. Now this only applies to this gas law. Okay, so at this point you've looked at all the different units for pressure, torr, atmosphere, mmHg, all those things. But for ideal, you want to be in specific units. So for pressure, you want to be an ATM, and if you're not, then you can just convert it. For volume, you want to be in liters. Again, this is just for ideal. So if a problem gives you milliliters, then you're just going to convert it to liters. The difference here is this variable N. And N is moles, which I know is from your favorite unit. This is looking at the amount in something. So obviously, if a problem gives you grams, then you would have to convert that to moles. But that's the one factor for ideal that's a little bit different. So N, you want to be in moles. R is the universal gas constant. Okay, so that means this number is always the same. It's never changing. And that number is 0.0821. And here's the units for this gas constant. It's liters times ATM divided by mole time Kelvin. Okay, so this is really important that you know this. This will always be the value for R. Okay, and lastly, T, which is our temperature. The units for all temperature, for all gas law problems, hopefully you know you've seen this by now, must be in Kelvin, and that's abbreviated as just a K. Remember, if the problem gives you Celsius, then you just add that number to 273 to give you Kelvin. Okay, and again, that's for all gas law problems, must be in Kelvin. So if you make sure that you're in these units, when you're solving ideal gas law problems, it's just going to be a plug and chug from there. Okay, so let's look at an example to see what this looks like. So remember we have PV equals nRT. And let's start from here. So in this example, it says how many moles of oxygen. So I know I'm looking for moles, which is N. So N I don't know. Must be placed in a 3-liter container. So that's a given. In order to exert a pressure of 2 atmospheres at 25 degrees Celsius. So the first thing I'd recommend is just labeling the variables. So we already said that we're looking for N, which is moles. It's placed in a 3-liter container. It's in the right unit, so we're good there. That is volume. So we have 3.00 liters. And again, if that were milliliters, you would just convert it first. In order to exert a pressure of, notice the units is in atmospheres, so we're good. That is pressure. And I know that that's pressure just because I know the units for pressure. And so hopefully by now you recognize all of those different units for pressure. And then lastly, temperature. Notice that it's not in Kelvin, but that's okay. So we're going to take 25 degrees Celsius and we're going to add 273. That's the magic number. And that's going to give us 298 Kelvin. Okay. So now that we have our variables, it's literally just plug it in, and you can manipulate the formula if you want first or after. It doesn't matter. It's up to you. I'm going to plug it in as is and then just go from there. So P is 2.00. V is 3.00 equals N, I don't know. R, don't forget R is always the same. If you want to write it down, you can as you're given. It's always 0.0821. And check it's liters times ATM over moles times Kelvin. So we're going to plug that number in, 0.0821. And then lastly, temperature, don't forget you're not using Celsius, you're using the Kelvin, so times 298. So when we do this, we have on the left 6.00 equals N times, we have 0.0821 times 298. So that is 24.4658. And a good rule of thumb is don't reduce or don't simplify or round until the very, very end. So from here to get N by itself, I'm going to divide by 24.4658. What I do to one side, I must do to the other. Four, 6, 5, 8. And you should get 0.245, so I'm going to round that to 0.25, and that is moles. So because it's looking for moles in the problem, that is our final answer. So hopefully that helps you in solving ideal gas law problems.